Right now this circular motion. Write the topic as circular motion. Headline, the most circular motion, right? Right. Now this circular motion. Write the topic. Uh, what is the motion, right? If any body which is moving along a circular path which is having a fixed radius, that's about any fixed point, right? We can consider it as a circular motion. As examples, we can say that's Earth rotating above the sun and satellites moving about the rotate also moving around the Earth like that. So the motion of a particle at the edge of the uh, sand bed, those are making circular motion, right? So you write the definition, just write there. When a body moves along a circular path, when a body moves along a circular path along a circular path around a fixed point or an axis around a fixed point or an axis or an axis outside it as the center, outside it as center, that's it, that's the center. The body is said to perform circular motion. Yeah, that's kind of right. It's moving along this path, that's with of radius r. This part, we can consider this kind of motion as circular motion. It's moving about this around this path. Okay, then write the examples. Write some examples. Right there. Start. The Earth orbiting around the sun. Earth orbiting around the sun. Earth orbiting around the sun. And second example, right in the storm, a storm attached to the end of this string. That to a end of this string. End of this string being whirled. inward around a circular path. And another example, right, is a motorcycle or vehicle motorcycle or a bicycle taking a circular spin. Taking a circular spin. Next is this motion of a rotor. Like those, right? That's the motion of a satellite. Also, you can consider. Right. These motions. Some examples for circular motion. We're going to discuss one by one, and to make a circular motion, there should be some conditions we needed. We know that already. It should have the centripetal force. Hi there. Hello. I'm waiting until you are finished writing. Hello. That's the Tell me now. Hello, hello.
ඔව් සර් එහෙනම්.
Deliver.
ඔව් සර්.
Oh, then right there. Right. When an object is performing, when an object is performing, an object is performing a circular motion, in a circular motion, motion, centripetal force, centripetal force should be there to provide the necessary force. Centripetal force should be there to provide the necessary force. Necessary force. Okay, then I centripetal force. Right, the right of gas centripetal force. Do you remember we discussed the centripetal force and centripetal acceleration? And we wrote the equation to write how we write the centripetal acceleration also. Would you remember that part? කරන්නේ දේ ටික.
ඔව් සර්.
Right, right. අපි මෙතන නිකන් little bit පද කියලා කියනවා විතරයි. So you know already that centripetal force then. Okay, then right under the centripetal force for a particle moving in a circular path, for a particle moving in a circular path, in a circular path, it has an acceleration towards the, it has an acceleration towards the center of the path. To the center of the path. Then right, according to Newton's second law of motion, Newton's second law of motion, the particle mass experience particle must experience a net force towards the center of path. Towards the center of path. And this force is called the centripetal force. This force is called centripetal force. Centripetal force, right? That's the name. Then write that's if simple AC is the centripetal acceleration acceleration, then centripetal force is given by that C, the C equals M AC. Yes, we know that's a C, that's here you can write its velocity is V and radius is R. Then AZ, the centripetal acceleration, that's should be equals to the R omega square O M, that's V square R. And this is you can write in V square R. Or you can write this epsilon also MR omega. You can write the centripetal force in terms of the speed or angular speed and the radius. Clear? You write up to this one. This is centripetal force. You can directly use this equation when you're making calculations. Right? Right. It's okay. You want it? Hello.
කනෙක්ෂන් ආව ගියා කලින් ස්ක්‍රීන් එක චුට්ටක් දාන්න.
Ah,
Right, sir.
Right. Then this constitutes centripetal force, right? You know that the centripetal force is not a new kind of force, right? So that means in the system they have to having some forces. They need to supply the centripetal force. It means that's it may be tension, it may be a gravitational force, it may be the sum of two, three forces, or it may be a component of force like that. So it needed to be supplied by the system. It's a new kind of force, right? Within by can write put Einstein right then it's better. The right as centripetal force is not a new kind of force. The force is not a new kind of force. It may be gravitational force, tension, friction, or component of the force. Extract, right? Right. Let's write it down then. We know that if the body is performing a circular motion, say body is there, it's moving forward this point as in making a circular motion. Let the velocity is V here, and then let's say string attached to this point and this rotate. And then tension, in this case, the tension supply the centrifugal force, the mass of the body is. You can feel when you rotate this car once, and you can feel any force on your hand when you rotate it, and they are having tendency to move this body radially outward. Right? If the string cut, the body will move radially outward. Then. So it means you that they are having another force. We can feel that one, right? They are having another force towards the outward, radially outward on the body acted when it's moving along the circular path. Also, when you take the vehicle, the vehicle is moving on road and is taking a bend, you can see that's the force exert on you to outward, right? That's why when you're taking the bend, you already all the person inside the passengers inside the vehicle, they move outward, right? Radially outward. So the reason is that the same thing. That's they're having another force acted on the body when it's making a circular motion. The radially outward force is there. So it's can feel only the person way inside that system on the outside reason they cannot feel that force. So that force is called the centrifugal force. Right? So in a centripetal force and also centrifugal force is also there uh, when the object is performing a circular motion. So then write it as a topic then centrifugal force. Right, centrifugal, right? Centrifugal chemical thermocouple. So here, the outward force appear. Let's see this. To describe this one, it's better we need to consider. Then write down the consider a block of mass, simple m. Consider a block of mass, simple m, placed on a table, at a distance, simple r. Placed on a table at a distance, simple r. From its center. From its center. From its center. Then write, suppose the table rotates with constant angular velocity omega. Suppose suppose the table rotates with constant angular velocity omega and block remains at rest with respect to table. Block remains at rest. Remains at rest with respect to table. Right. Okay. Can you see this body? There was the thing given here. Right. Can you see this?
Yes, sir.
Right. Then you need to draw it, right? Here, this is a free body diagram of the block in initial frame. Initial frame means that's a this observer here. You can see here. This is observer. Right, this observer. This observer is outside of this rotating table, right? So he's an inertial frame. This the frame and it is not accelerating. But this observer now here, this observer is on that plane. That means that he also accelerating with this body, and it's in an inertial frame, right? And the forces acted on this body with respect to this observer marked there. There's a weight is downward and the normal reaction capital N and the friction was there. So these are all the forces acted on this block with respect to this inertial frame observer. And but in here, according to this Newton's law, you can see here that's a body with respect to this man. This body is not moving, right? That's both every time the mass and this block are in the same separation. So then, according to him, there's a friction, then there's another force to other side to balance it because with respect to this person, this body is not moving. It's not moving, it's stationary because you can see when you moving on in the merry-go-round, you can see the person inside the merry-go-round with respect to you, all the other person are not moving, right? You can see them at the same distance at each time. But with respect to the observer outside, this object is moving always. So then there is no force acted on this because of no motion. So then the friction should balance by the another force. That means the radial outward force should be there. So that is called the centripetal force. But that centripetal force can feel only the observers are in non-inertial frames. For the observers are in inertial frames, they can't see this uh, centrifugal force. Clear? Clear. I'll
Yes.
write it down. First you draw this and I'll write it down, then write it down and let me know. මදිනවද?
ඉවරයි සර්.
All right. Then let's consider the motion of the block relative to an observer on the ground. Right. Let's consider motion of the block relative to an observer on the ground. And then back and right as initial frame. So on the ground. Yeah, then right in this frame, the block is moving in a circle of radius r. In this frame, the block is moving in a circle of radius r. Therefore, it has an acceleration. It has an acceleration that az that's equal to v square r towards center, towards the center. Then right, according to this frame, or this observer, according to this observer, forces, according to this observer, the forces on the blocks are forces on the block are right. The first force is weight of the body. That's weight. That is mg. You can write it down. And the second force, the normal reaction. That's capital N, which is upward. Capital N, right? And then the third one, what was third one? That's the frictional force. Frictional force. That's the symbol F here. Frictional force by the table, right? Symbol F here. That's the force one, and that's along toward the center actually. Okay, these are the forces. So then by Newton's second law, that's something called MA. You can write. That's towards the center you apply this. That's the friction force in equals M. So V is cover R. And upward force is balanced by the normal reaction, that is balanced by the weight. And this that's the way you write it for the circular motion for a body moving about the axis with respect to the observer outside the rotating body or at any initial point. But that's forces and the other things are different observed by this observer is on the table. Let's see the motion with respect to. Okay, up to now it's okay now. හරිද? Hello guys. Hello ඇහෙන්නේ නැද්ද?
හරි සර්.
Thus, Lena, now consider the motion of the block with respect to the observer. Now consider motion of the same block with respect to the observer in a frame attached with the rotating table. In a frame attached with the rotation table. So,
The same block with respect to the observer.
with respect to the observer in a frame attached with the rotating table. In a frame attached with the rotating table, right? Then, right, the observer here finds that the block is at rest. The observer here finds that the block is at rest. Okay. Then, right, the observer here finds that the block is at rest. Right, thus the net force on the block in this frame must be zero. Thus the net force on the block in this frame must be zero. right? Then it was on the block in this frame, marking 0. Right, the weight and normal reaction balance each other. Weight and normal reaction balance each other. Balance each other, right? Right, but frictional force acts on the block towards the center of the table. What? Frictional force acts on the block towards the table, center of the table, towards the center of the table. To make the resultant 0 towards the center of the table, then full stop and write there. To make the resultant 0, a pseudo force. A pseudo force. Pseudo force means that's a fictitious force. Pseudo force. A pseudo force must be assumed which acts on the block away radially outward. Must assume which acts on the block away radially to outwards, heading outwards, and has a magnitude that's mv square r. And this pseudo force is called centrifugal force. Centrifugal force. Clearly, within forces acts on this body with respect to the opposite is true and is true. So, then right there in this frame, the forces on the block are this frame. Forces on the block are forces on the block are the first one that's weight that's mg, that's downward, and secondly is in the normal reaction. Capital N upward, and third one frictional force. Left towards the cylinder. Pause. Finally, centrifugal force. Centrifugal force. Let's in this cover this radial outward. So to balance this, it should be if minus in this cover, that should be zero because that is not resultant. So you can write in F to be equals to M this cover. The same result you can obtain with the other the server and the other frame also they will be the same way to write this. So in this frame also they given the same result. Let's write up to this. Right. Then we'll go through some applications of this centrifugal force, right? Centrifugal force in that's uh, the centrifugal force. Another thing I will tell you about this thing. The centrifugal force also we need, right? You can see here, this centrifugal forces are used in the washing machine. You can see it in the washing machine. That's a spinning part. It's a tire part. You can see inside it there's a cylindrical one there, and there's a hole on the wall of the cylindrical part. Can you see this for him in the washing machine? And if you put cloths inside there, the wet cloths, and what's happened, the principle is there, it's rotate to faster. When they're rotating faster, what's happened is cloth inside is will squeeze out, and it's squeezed, and then the water come out from the cloth. And these water molecules, or water particles, due to the centrifugal force, they send towards our radial outwards. That means they send towards the wall of the cylindrical parts because of the centrifugal forces. So then, if there is a hole, that means there's a hole on the wall, then this liquid go out. That's how that spinning part works. And also the centrifuging, another one is centrifuging to separate the liquid and solid in a precipitator. You can say then this two test tubes you can use like this, and they are hang on the part, and then they rotate this. When they rotate, and the liquids separated as liquid and solid parts, because the higher dense particles they're having higher centrifugal force, so they goes to downward. They goes to the edge, let's say outward, then they come to the bottom. That's how this will works, the centrifuge. This is a spinning outward machine. We cut the right there. There's some applications of centrifugal forces. Write it down there. Right? Some applications of centrifugal forces. Right. Are there?
Hari sir.
Okay, then I will write there. First one, right? And the first one, right? That's spinning of a washing machine. Trial spinning of a washing machine. Then it's spinning. When I under that idea, the centrifugal force acts along the radius in an outward direction. Centrifugal force acts along the radius in an outward direction, and hence can be used to can be used to throw. Means can be used to throw the water molecules on the cloths radially outwards. Can
Very
be
good.
used.
Thank you, Anuvichutta.
Take a right then the centrifugal force. Centrifugal force acts along the radius in an outward direction, and hence can be used to throw. So the water molecules on the cloths radially outwards. During the spinning of the washing machine. Yeah, spinning of the washing machine. This helps the drying the clothes in the washing machine, right? Dry in organic water design. The second one, right? Centrifuge tubes. Centrifuging, second one, centrifuge. Centrifuge, right? In chemistry, they use this. This kind inside solids, the liquids. It means it's a precipitate. You're rotating it due to centrifugal force on the solid particles higher than the liquid. So solid parts come to the bottom of the tube and liquid will be on the top. So then it separates clearly. Then this is the method we use to measure that's a blood testing. Also, that's red blood cells have heavy, the iodine, so they goes down like that. They stacks with the different density of layers Device they stack on the tube. And then they do make the blood test, blood separate kind of thing. Right, as scientific, you can draw this small figure and then right there in the century focal force on solids or greater than liquid. So solid, solid particles um, become the tube when rotate. It's easy. It's easy to separate liquid and solid in a precipitate. Precipitate, right? So that's the you can write. Draw this one and write. Right. Okay. Then write another example. Example, that's another application. Then write there when a when a car in motion takes a sudden turn towards the left. When a car in motion takes a sudden towards the left, turn towards the left, passengers in a car experience an outward force. Sudden turn towards left, passengers in a car experience an outward push to the right. Right. So that's due to the centrifugal force. Okay, that's enough for the another one. That's a bucket. You can see here. That's this is third one, the fourth one. So you can do it at home also, right? Take a small bucket and fill it with water, some water, right? Then on this string, and then rotate it fast in a vertical circle until that's when the bucket is going over your head. But that's all the opening of the buckets are below. You can feel that the water will not be dropped down. You can do it at home and then see. Because that's because of the centrifugal forces act as radially outward. So this water is bonds to the that's say leans to the wall of the container. That's why they will not come down there. Right. So that one you can write then. Uh, a bucket full of water. A bucket full of water is rotated in a vertical circle. Particular speed. So that the water wall is also because of focal force. Right. These are some applications related to this centrifugal force. In these cases, the centrifugal force acts on the body to maintain this stability. right, in right there. Yeah. Then you want circular motion applications together. Right, some applications of interpreter force. Applications of centripetal force. Standard as conical pendulum. Conical pendulum, right? This is the pendulum which is rotating as a cone. As it make a cone, right? Conical pendulum. Yeah, under the right, let's consider a conical pendulum of length L. Length L. Right, it is made to rotate. Made to rotate. It's made to rotate about a vertical axis. For a vertical axis. Cause string of pendulum. Pendulum, string of pendulum. Let's make an angle theta with the axis. Okay. This pendulum is moving along a circular path as moving the right controls. In angle theta here. It's moving on. Weight of the pendulum is downwards, that's the mg. Tension on switching. String length G. And then it's angle theta here also. Let's see, it's moving with the velocity of v here. Oh, that's angular velocity mark this one, like the omega. Draw this. The tension T here, right? The centripetal force is given in the system that's towards the center by the component of the tension. That's basis of this is R and length is L. First, you draw this one. Okay. Now we need to write the equation for this, right? So here then you write in here the centripetal force is right there, right here. Centripetal force provides by centripetal force provides by divides by the horizontal component of the tension. Horizontal component of the tension of this joint. And this supply the centrifugal force. Then you can write an equation for this one, right? Using equivalent second law towards the center, then force is then beside it's the component of the force is T sine theta. And upward it is T cos theta. Sine theta, that's equals to mv square r into the acceleration. And then upward was you can write the cos theta, that's equals to the mg. And divide these two, then the divided by 2, you can take that tan theta, you cancel out, then the answers are cancel. Please go arch. Speed you can add equals then RV tan theta square root. But the R is not given here, that's the length only. We know that the sine theta also equals to the R divided by length also. R equals then L sine. Substitute L also, then omega is equals to V divided by R. So V equals to also R omega. Then you see V you can write R omega. You can write R omega here. Then you can find omega also. Omega over time period in you can write. So substitute this value the V, that's R, because instead of R, L sine theta you put there. So then L T sine theta, tan theta, square root of this. I don't have enough space there, I'm writing here. P equals then R omega, that's equals to the LG sine theta. Tan theta is also sine theta divided by cos theta. This R means that's L sine theta. That's omega. And here sine theta, sine square theta, let's take out sine theta. Take out then L G divided by cos theta. The square root of this sine theta cancel this omega, then L goes to the other side. So then L will cancel G L cos theta. That is the omega. Omega, why we need to find omega? This time period equals to 2 pi divided by omega. So then this 2 pi times L cos theta divided by G. That's the way you find the time period of this conical pendulum. You can write this equation. Could you remember this writing this one, this point? After this one, we need to write this part. Right? If you clearly finished, you can let me know. All right. Then next second one, right? Rotor. The rotor. Okay, this is just like a cylinder, right? This is like a cylindrical one, but the main there's no bottom, right? The bottom will not be there. So we can rotate it. Or that system. Man can be there inside, and it's there. There's no without the bottom. When the rotor is or that's rotating, the man can be there because of the central forces acted on it. So that the forces acted is normal forces acted on it is R, let's say, and the friction applied on it is then let's see F, and the weight of the body namely mg. Right. We can draw it and mark these forces. The radius, let's say the simple R, sorry. Right there, let's consider a rotor. That is a so vertical cylindrical device rotates its inner wall. The wall that I'm writing without the bottom. Complete. No, complete is there. So also then I will apply figure MA here. That's you can write this. Sorry. That's important thing because we are from. That's a sort of centripetal force. Centripetal force on the man, the person, to maintain motion is given by the normal reaction. Normal reaction from the wall. Yes, then I will apply figure MA towards this point. That's a normal reaction. That's equals to the this is rotating with the angular velocity omega. Let's see, that's r omega r omega square. Mass r omega square. Upward process, if there's no slipping, the frictional force should be equals to the weight then. That should be equals to m. Because of the friction here, the friction equals that's mu into r. So then you can write in the that's equal to mu. R you can write on this equation that's m r omega square. So omega then equals m and m cancel, right? You don't need to write m there. It's a mu that b over r. So this mu is that's a v zeros there, the maximum friction. That's a limiting one. That's why we can write mu r. So if mu r if that is maximum means omega will be minimum. This is the minimum angular speed with the rotor to rotate as the person inside is not fall down. That's a can hold. There can be rope there on the with contact with the inner pitch side. This is the minimum speed of rotation of the rotor. If that speed is less than this value, what's happened then the person will fall down. Is it clear for you? The minimum
Yes,
speed
sir.
of rotation of rotor. But I think this is minimum speed of rotation of water as the man should be allowed there, right? Okay, write it down. Okay. Then write the next application, that's a motorcycle taking a circular bit. You're taking a circular bit, right? Okay, then write that. Consider a motorcycle. Motorcycle, or a bicycle. That's moving along a circular bin. Radius r. The speed will be correct. Okay, then write the centripetal force needed for this motion. Is provided by the friction. By the frictional force, right? This friction. I'll draw some diagram there to show you how those forces act. How we can draw the bicycle. So my writing is the bicycle wheel is this. It's come towards us. And then the bicycle it's come towards us, right? Then is riding the bicycle. See here. Okay, now I will mark the forces acted on this part, this situation, right? There's friction, lateral friction. So when you take the, this is the bicycle when it's moving a circular road, right? I'm writing. See here, this circular road is there. Circular, I will turn the car. See you, unexpected process hidden in the centripetal. This will turn the car. Taking a turn, right? The force to this direction, and then the weight. The bicycle, let's say the center of gravity is somewhere here. The weight is downward. Then the normal reaction. Now the forces acted on this somewhere here. I put G, the center of gravity. And then normal reaction there. And the weight, this friction. First you draw this. Then you need to draw it again and again. Okay, these are the forces, right? When you draw it, another one, another figure, right on the side. This is the wheel of the bicycle. ඒ කලින් එකම තමයි හැදෙන්නේ. දන්නේ center of gravity is there. In, for draw the forces then is when this is taking a rod and the centripetal force through there, but they come, it tends to come the supporting force acted on the center of gravity. Then. It goes to this direction and weight should be downward then in the power action also. There's another way then we can consider this force as equal force we apply to there and there another equal force, nothing changed. Two forces acted on the body equally and opposite then. Why I'm drawing this, I'll let you know how to do it. First you draw this one and finish. Yeah, this is moving on a circular road, right? Now, I need to balance this because this they're having a torque on the body. That's at the moment. So then it's caused to fall down. So then you need to lean or tilt the bicycle to take this turn. If not, it's cutting really outward and this. හරි නිකන් මෙන්න මේක මම කියන්නේ වාහනයක් ඔයගොල්ලෝ දැක්කා ඇති ඔයගොල්ලෝ දන්නේ නැති බයිසිකලයක් තාම ටර්න් එකක් ගන්නකොට මේ වගේ ඇල කරනවා ඒක එන්නේ කොහොමද කියලා. ඉතින් මේක ඉස්සලාම ඔයගොල්ලෝ ඇදගන්න ඊට පස්සේ ස්ක්‍රීන් ගන්න තමයි ඒක. ගන්න ට්‍රැකර් එකක් ගන්න ට්‍රැකර් එක නම් හරි. පොඩ්ඩක් දැන් ඇලවෙලා. හරි. Center of gravity is SG. And drawing the forces acted on it. Normal force is always perpendicular to the surface. Friction matter is there. The weight of the body. I'll draw this frictional force. Okay, here that these forces the R here, and this is the weight now. It's tilted, right? We know that something has happened. ගන්නකොට bike එකක් bicycle එකක් tilt වෙනවා. Let's see the triangles make to the vertical is theta. Here also it's theta. And this frictional force and frictional force and this frictional. Anyone can I will explain this. Let's say the height is h and in the distance between this is d. Okay. Okay, Shana. Very good. Delivering. එකම මිනිස්සේ හරි වෙන්නේ. නැත් එකෙක් වගේ වෙන්නේ. හරි. අන්තල ඉවරචන් කියන්නේ. Okay, here in the maximum frictional force, there is a limiting friction, right? No frictional force because that's limiting friction. Taken as the Z dash, that should be equal to then mu r. Hence, for circular motion, of the cycle without slipping. Spin, what should happen? Its centripetal force should be less than or equal to its maximum friction. Because that force cannot be exceed this one because it not slip. So this centripetal force is equal to the m square r then that should be less than or equal to mu r. Okay. So here you can write this the mu r. We know that's the mu r that's equal to mg. That's mu mg actually because there's r equals mg in this case. There's no vertical motion. Vertically the forces should be balanced. That's the r equals mg then. So then you can write substitute in there. This is mv square r. That's equal to the mu mg by considering this mu. You can say that v square should be than or equals. This is not equal. This is than or equal mu r. So then v should be less than or equals mu rg square root of this mu rg. So then the minimum speed, that's maximum speeds, which this cycle can take a turn without slipping is mu r, square root of mu r. But the problem is if mu will be changed with the time, right? So if it's a rainy day, there's mu is much less. So then based on this, is the maximum speed cannot be still. So that's why to take it much more, it's a high speed in the moving, they need to lean or they need to tilt the vehicle. So let's see. First you write up to this point, then let me know if you finish writing. Alright. So then right there, however, since this centripetal force has to act, always this part then right. However, right there, however, since this centripetal force means this centripetal force has to act at the center of gravity. Gravity, that's capital G of the system. Couple of forces tending to topple system begins to act that on each as shown the figure, right? Then in order to prevent the toppling, the system, the motorcycle and ride. System means as motorcycle and rider. In performance on the couple of forces. On the and the normal reaction. Are on the system, right? Okay, this is write down. I will let me explain you what's happening there. Okay, here the thing is when we take this from right, take a circular path here like this, you take a circular path. Then there's centripetal force is given by this friction here, right? So this actually the centripetal force is not acted on this tire. It's acted on the center of gravity. So then when it's in the rod, the turn, the centripetal force tends acts on this center of gravity towards this here. And then equal force of that centrifugal force that's force acts on the we can consider this force is acted towards this direction, the centripetal force then the center, the other right. So in the outward there's force on acted on the same point there. So then this centripetal force they are right. So then this one and this one. Because you can see here there's no resultant force acted on this because only the resultant force is given by the centripetal force, right? But this one and this one use a couple to couple to this direction. So, okay. In this couple, this tends to topple then, topple out. So then to prevent the toppling, what should happen then? That's we need to make a turn, that's a torque to the other direction, counter torque, right? So then that's why the man should tilt the vehicle. So then the weight will come to there and then normal reaction is the normal reaction and weight creates you the topple. That's a couple to this direction. So then this couple will balance with the couple formed by these two. So then the vehicle can take the turn that bends without toppling. If not, it will topple. And first the slipping case, now the toppling case. So then right hence to prevent the toppling, right hence to prevent toppling. Prevent the toppling, that's the torque given by the weight. I'm taking the torque, that's here. I'm going to do this thing. I'm taking the moments about this point, then the moment will not be considered from this force and only the moment come with this one and this. This is not a force acted here, that's the same force you mentioned there, right? That is a centripetal force. mg into d that should be then equals to the mv star r in the h there. So then d of h you can write that's equals to the v star rt. So d of h according to this figure you can see that d of h equals to tan theta. Tan theta that's equals to d over h there. So then you can write this side d of h is tan theta. So it's equal to v star r. If you increase the angle, then you can speed up the speed, the velocity. So it's more angle, the angle is the larger the angle, larger the speed you can take. That is for not of the. Then you can say therefore the angle of bending depends on the speed of the motion. The higher the speed of the motion should be the bending towards the ground. It's clear? Then motor vehicle එකක් ගන්නකොට ඊට වඩා ටිකක් flat road එක ආවත් කොහොම තමයි බෑන් කරන්න ඕනේ ටිකක් වැඩි ස්පීඩ් එක ගන්න. මේ සතියේ ඉස්කෝල නිවාඩු දුන්නාට පස්සේ අපි තව දවසක් weekday එකකට යන්න බලන්න ඔයගොල්ලන්ට. ඒවන් දවස් මට දාලා කියන්න වැටෙද්ද? Then I will pick another class. Because last week also we missed. හරි නේද? පිළිවෙල. It's idle strike. So finish the writing like no. Okay, then next one, right? There's a banking of fraud. Then if a vehicle is moving on a road that if the friction is not sufficient, then this that kind of roads they bank. Road banking. You can see in the racing tracks also they make the racing tracks also the minimum. මේ ට්‍රැක් එකේ පාර තියෙන පොඩ්ඩක් මේ මෑල වෙන ලොකු ඇල යන්නේ කොහොම ඒ වගේ නිකන් මෙහෙම පොඩ්ඩ ඇංගල් එකක් තියෙන රෝඩ් එකේ කොහොම ඉන්න රෝඩ් එකේ having some angle banking just like a dead wheel තියෙන කානිවල වල මාරකලින්ද කියනවා ඕකේ ඔන්න එක තියෙන ටිල්ටින් එක නැත්තම් ඒකේ ඔය තියෙන වාහන වලට යන්න බෑ හරි ඉතින් අපි දියමු ඉඳ road banking කියන්නේ මොකක්ද කියලා what is road banking the right there on circular path on circular path if frictional force is not enough if frictional it is not enough to provide us to provide the required centripetal force the centrifugal force. Then the outage of the rod is raised with respect to inner edge. Inner edge of the rod. This is called the rod band. Banking of rod. Okay. The banking of rod. I'll show here that's a section, right? You know, they give him that's a construction is there. It's not the banking the everything. I'll show it. Let's say that the vehicle is more on this road there, right? I'm drawing small vehicle, yeah. Is vehicle will come towards us. So there's a center of the circular path. Forces act on the vehicle like a marking. You can write there first, right there. Consider a car of mass simple m. Right. Consider car of mass m going on a circular path going on a circular path of radius simple r with the speed v. Radius r with the speed v. Right, the outage of the road is raised. Outage of the road is raised by simple h with respect to inner edge. By simple h with by simple h with respect to inner edge. Okay, then I'm considering here that's you can see this B is the breadth, that's the actual breadth of the rod. The W is the width. Width means the rod width. මේක දැන් මේව තිබ්බට මේ පොළොවේ යට නෙමෙයි ටික තියෙන්නේ. It's difficult to measure. But we put this banking කියලා අංශක ගණන් ඇර කරන්නේ small. That's the theta is very small. So then we can say that D and W are similar. Boston. Then this according to the figure you can write that tan theta it's equals to the H divided by B. H divided by B. So this approximately equals to H star W because theta is very small. Then B approximately equal to right. Okay. Then මේක මෙහෙම තියෙද්දි මෙයා outward යන්න ඉඩ තියෙනවා. මේක වේගය උනාට වඩා අඩු වුණොත් පල්ලෙහාට ඉස්සර යන්න ඉඩ තියෙනවා. ඒකට දෙපැත්තටම බලන්න. There's maximum and minimum speeds to maintain the motion along this path. In a depth well also, if they reduce the speed, they goes downward, and if they increase the speed, they going upward. So then එළියට විසිකෙන්න පුළුවන්. පල්ලෙහාට තල්ලු වෙන්න පුළුවන්. We are going to discuss both parts, right? Control here that says this angle is theta. You can see this is also theta. So anyway, when you have friction, simplified Prego diagram. That's R here. That's the vertical direction. That's the weight of the volume. And this tilted angle is theta means that's this angle is also theta. This is the horizontal, right? This is theta. This is 90 minus theta, right? This also 90 minus theta. Right, right. This theta and this was theta and this one also theta. This is theta, this is 90 minus theta. Vertical this is also theta. Then this is the frictional force, normal reaction. So then the centripetal force for this motion is given by this component of the normal reaction and the friction both. Right leg tendency of car is to slip up this correspond to maximum speed, right? Then උඩට නම් යන්න තියෙන then the friction come downward, right? It's only elevation. So then we can consider the forces that along with this. There is equilibrium in vertical, say. So then R, the upward force is R cos theta. Downward forces are in mg plus F sin theta. F is a friction. And if you can write that is equal to mu R. All this maximum friction you consider. So then you can write that if you take this side then R cos theta minus mu sin theta, mu r sin theta. That's equals to mg. The first equation you can write like r cos theta minus mu r sin theta is equals to mg. Clear? The centripetal force is given by the component of this force and the component of this one. This comes towards the radius. This is the radius from here to here. Center is the radius, right? If you finish the writing, let me know. Then I will turn page to the other side. හරිද?
හරි sir.
Right. Then same way you can write this F equal ma towards the center of the circular part. So then this side the force we have, that is r sin theta is the component of the r, and F cos theta is the component of the friction. This should equal to mu, mv star r. That is the centripetal force, right? The centripetal force is given by 2 r sin theta and r cos theta. You can see here, this will be here the r sin theta and this will be r cos theta. Then again you can substitute that sin theta and plus mu r for the F friction. Cos theta is equals to mv star r. This is the second equation. And then you can divide this second one by the first one. You can write then r sin theta plus mu r cos theta. First equation, to remember this r cos theta minus mu r sin theta. That's equals to the mv star r here, and then below one is mg, other one is mg, though m cancel, so you can write mu v star r. Directly divide this r, all this area, r you can take out and cancel out. Then this equation becomes that sin theta plus mu cos theta divided by cos theta plus, minus mu sin theta. That's equals to the v star rg. This corresponds to the maximum speed of this. Okay. You can divide this all the terms in the numerator and denominator by cos theta. Right? Writing this in dividing numerator and denominator. Each by cos theta by cos theta. You can divide it with sin theta divided by cos theta, you get the tan theta. And this mu cos theta divided by cos theta, it's only mu there. Cos theta will cancel. And this cos theta divided by cos theta is minus 1. Mu sin theta divided by cos theta, mu tan theta. So sin divided by cos tan. This is our r. Therefore, you can write therefore the maximum is speed. Maximum speed. Yes, this is the maximum because that's the maximum friction we use. That's why, right? So we use the maximum speed. Tan theta plus mu So මේක බලන්න මෙතන mu is the largest value මෙතන large වුණාම මේ numerator weighting large. So plus there. And your denominator is getting minimum. That's large also. That's a large. මෙයාගේ අඩු වෙන ප්‍රමාණය වැඩි වෙනවා. Denominator වලට අඩු. Then the maximum speed is in RG times mu plus tan theta divided by 1 minus mu tan theta. That's square root of this. According to this equation, that's a previous one. You can write that when you try gaining the table, the maximum speed is limited by this R mu RT. Previous case. But here, the tilting angle is also need to be considered. Then it's also given some significant value. So then, minimum if there is no friction, let's say that's a smooth surface there. So then, without slipping, you can take the turn. Because of the road is banked. Bank road එකේ under friction නැතුව වුණත් යන්න පුළුවන් ඒ. Sorry, friction තිබ්බත් friction නැතුව වුණත් යන්න පුළුවන් because bank වෙලා තියෙන නිසා centripetal force එකක් sufficiently සපයන්න පුළුවන්. ඒ තියෙන angle එක. Clear? දැන් එහෙම යන්න පුළුවන් කියලා දැන් bank කරපු road එක අපිට හිමින් යන්න බෑ. හිමින් ගියොත් ඒකට ඒක road පාරේ පල්ලෙහාට දිස්සන්න පුළුවන්. I'm writing that if tendency of car is to slip down the plane corresponds to minimum speed of the plane. දැන් එහෙම වුණාම වෙන්නේ එහෙම. ඒක එහා පැත්තට දාලා ගන්න. හරිද? ඊට මේ friction එක එන්නේ මේ පැත්තට. හරි. Friction is come upward. කරනවා නම් එහෙම තියාගන්න. because then the friction come upward, right? ඒකට මේක මෙහෙම. හරි මේක මේ පැත්තට එන්නේ. ඒතකොට එන්නේ මෙන්න මේ forces වල මෙන්න මේකේ ලියද්දි මේ equation එකේ r cos theta plus mu r sin theta. r cos theta මේ f තියෙන උඩට f ගේ component එක. So r cos theta plus mu r sin theta equals mg. එතකොට centripetal force එක තියෙන්නේ r cos theta minus mu that r sin theta. ඒ sin theta ඉන්නේ අනිත් පැත්තට. එතකොට මෙන්න මේ තියෙන equation එකේ මෙතන plus minus වෙලා මෙතන plus වෙන එක. plus minus change. So then we don't need to write it again. Then you can write then the car then according to the previous case. Then you can write then may equation you can write for minimum one it is a mu minus tan theta divided by that's 1 plus mu tan theta. Mu minus tan theta minus mu divided. So mu part එක තමයි minus. So then you can write this minimum speed then equals this RG. The tan theta minus mu divided by 1 plus mu tan theta. දැන් මේක එහෙම ආපු හැටි තේරුනේ නැත්නම් එකපාර අර ආය අර වගේ හැදලා ලියලා ගන්න ඕන ඉක්වේෂන්. හරි. මේකම වෙද විදිහට try කරලා බලන්න මේක මම directly ලිව්වේ ඒක forces frictional force only the frictional force its direction will opposite change it. So then you can write the mu accordingly. That's much not difficult. Easily you can get it. So using this equation, if this rod is a smooth one, then put the mu 0. So then you can get the equation for a smooth one. All right. Uh, Now using this equation, you can extend this in the diagram and management technique under the right. That's when no friction, into partially and when no friction, you can write this mu equals 0 then. So then above equation, you can write that's RG tan theta. That's here you can write this is 0 and this part is 0. So then it's RG tan theta only. So the square root of RG tan theta is the speed. That's a speed which the vehicle can move without slipping on this rod if there is no friction also, right? Okay, so
Okay,
it's
sir.
clear now.
Yes, sir.
All right, another point I'm addressing that in motion in a vertical cycle के लिए वो setting up the make right, the motion in a vertical cycle. Motion in a vertical cycle. Right, that's consider a body. That's right. Consider vertical again. Vertical cycle like make it in a minus time in a circular. That's a the horizontal circular motion. That the speed is constant. It's a no speed change. But in a vertical circle, the center of the centripetal force will changes with the time. So when it's moving, so then the speed also changing. That's why. Right. Consider a body of mass equal m. That's tight. I'm considering that's an example. Then I will explain this all. And it's tight to the one end of the string. Mass equal m, right? M tight to the one end of the string. End of the string. And may rotate in a vertical circle. Vertical circle of radius simple r as shown. I'm drawing. So this is the vertical circle. So it's moving, right? I will draw this with the dotted line. Okay, then the shade place here, let's okay. So I'm considering this now, this level, right? It's a potential energy zero level. This is the lowest point, and this is the middle point, and this is the highest point. This is the point where the point, that's point B here. The tension is T, and the weight of the body is mg. So in this direction has a speed, then that's a speed the weight. Let's see this is the O, and this lowest point. Let's see the speed is VF at the VL. At the highest point, let's say its speed is VL, because the speed is changes when it is moving in the vertical circle, and the tension at this point, let's say TL, and tension at this point, let's say TH, and the weight also downward. There's a weight mg there, and in this position, the weight is downward. The weight is downward mg there. That's the point L. Right? Here, in this case, the centripetal force is TL minus mg, and in this case, is TH plus mg. That's why that's the centripetal force changes. Accordingly, the velocity changes. And in here, this is the position where the angle is theta, is theta angle. Okay, now this radius of this circle is r. Now I can apply the let's called MA to the same thing, HP. What are the forces? That T in that direction minus mg cos theta in the opposite way, that's equals to m v square over r. So then I can write that T equals mg cos theta plus mv square over r. So this is general formula for the tension. So now we can write the tension at each point on this motion. And let's say that at L, when you write it at L, the lowest position, what are the values then? The theta equals 0. That's cos 0, that's equals to 1 day. And then V equals V. The tension you can consider T. By substituting these values for the equation 1, then you can write that TL, that's equals to mg cos theta is cos 0 is 1 plus m VL square divided by R. This you can write as second equation. And then at highest point, H, right? Then theta equals 180 degrees. Cos 180 degrees. Cos 180 degrees, that's equals to minus. V equals V. And T equals V. Then you can write substituting in the first equation also TH here, that's mg cos theta is minus something minus mg then plus V mvh and VH square divided by R. It's just third equation. Now I'm going to tell you that something like what is the condition there should be given the velocity at the lowest point to complete the circular motion without slacking the string. You know, that's if if speed is not sufficient at the lowest point you given, the string will not pass the complete cycle, and the string will slack before it's going to complete the cycle. So then it will not complete the circular motion. So that's another thing I'm going to find here. finish the writing, let me know then, right? Okay, so finish this and let me know.
Your eyes, sir.
Then we can get an idea, then, right? Here, according to these equations, the first one and second and third, you can see here the tension of the string will be minimum at the highest point because it's a minus mg plus mg star. This. So complete the cycle without slacking the string. The minimum tension of the string should not be equal. That should be greater than 0. If not, the string will slack before which reach to the highest point. Then write it there. That's a condition we write then. That's for completion of your completing circle without how the string slack or the string slack. The minimum tension of this string should be greater than 0. Just to provide the centripetal force, there should be the tension there. The minimum tension should be greater than 0. If not, the string will slack because the tension becomes 0 means the string will slack there. So having the minimum tension on the string, right? Minimum tension on the string at the highest point. So then the pH should be greater than 0. The pH equals minus mg plus mg star r. So this should be greater than 0. I will write the other side. Note that, right? Minimum tension is at the highest point. So we can write as pH should be greater than or equal to 0. pH is then minus mg plus mg r. It should be greater than or equal to 0. I'll take this mg to the other side. mg is star r greater than or equal to mg r. So cancel. So then vh star should be greater than or equal to g. So the vh should be greater than or equal to star root of p. It should be greater than or equal. This one means that the minimum one that should be g, star root of g. So if the speed and the velocity at the highest point is less than this value, which means it will slack before it reaches to this point, right? Okay. That's the condition. Then we can see, we can write the condition, what is the speed at the bottom. The minimum tension will be greater than this one, what is the tension of the bottom, we can write that. Then you can use the energy conservation. So this using energy conservation. Energy should be conserved because all the forces were done under conservative forces. That's why the energy should be conserved. Even this motion, right? So using energy conservation, I use for the lowest point and highest point. The kinetic energy plus the potential energy at the lowest point should be equal to the kinetic energy plus the potential energy at the highest point. Clear? So here you can write here kinetic energy is half mvl square. Potential energy is 0 because I'm considering this level as the potential energy. 0 level. And highest point, the kinetic energy half vh square and the potential in the mg, that's diameter, that's 2r, mg 2r. So you can write then kinetic energy is mv square plus 0 here, and here it's mvh square plus mv 2r. So m cancel out, so the vl square, you can multiply this by 2. So then the vh square plus 4gr. Then cancel, that's a 2gr, it's multiplied by 2 is all, and it's become 4. This is the relationship between this VL and VH. Here, this fourth equation I'm writing. And then VL square. If I put the minimum value of this VH, so then VL becomes minimum, right? So it's minimum. I'm writing the minimum value of this is square root of GR. We already find that value, right? The square. First, I write this to get the understanding in return. So this VH square, the minimum of VH, minimum of VH. So it's not clear. VH square, minimum of that. That's 40. We already know that the minimum value of VH, that is GR. The square of this is GR because square root will go on plus 4GR. Then the sum is then total 5GR. So the VL, the minimum value of VL, minimum value of VL, that should be square root of 5GR. Here. So to move without slacking the string, in the case of this is the string is slack, but in the case of the what which is moving in a roller coaster, let's say roller coaster, we consider roller coaster. So the centripetal force is applied by the normal reaction. So then to complete the full cycle, the normal reaction should not be 0 at a point, because if the normal reaction becomes 0 means it lose the contact with the track. So then the roller coaster cannot be moving. You know that the roller coasters are there in the vertical cycles making. Their minimum normal reaction should be greater than 0 there. And at the bottom, it should be given this much of minimum speed. If not, the roller coaster cannot pass through the top end. Yeah. So at the lowest point, it should given this much of speed to complete the cycle. This is very important because when you're taking a turn, that's aircraft also then taking a turn. They need to know that the vertical turn they're taking. They need to know that what is the minimum one, and based on that, you need to take off, right? So then it's difficult then. So this is a minimum speed. You can find the tension at this point also. That's using the second equation. You can say that's a TL equals then you can remember this mg plus mv square r, right? So mv square r. So then the minimum tension, because if you put the minimum velocity to there, that's mv plus m over r. The VL square, I'm putting this value 5gr. Then RR cancel, this is 5mg plus mv, that's total 6mg. So that means to make this motion, the lowest point, the tension of the string should be minimum is the minimum tension of the string should be 6mg. That means at least 6mg tension should be there. That's another point you can get in. If that breaking tension of the string is less than this value, that means the object will be, that object cannot make this kind of circular motion. Before that, the string will cut off, right? It's a breakup. So keep that in mind then. This is important when you make mistake. So let's then see that's what happened if this speed the lowest point is less than some value or greater than some value, because during the motion it can be as before spring slack, the speed can be equal to zero. In some cases, the speed is enough, but the spring can be slack if that sufficient velocity is not given at the lowest point. So then we can explain about the motion based on the speed at the lowest point. Okay, then copy it down and let me know if you have finished the writing. Right, then the physical conditions, yes, I'm also I'll do some question after this thing. Let's see the what's happened to the motion. Right? So these are the that's the critical values. No? So then what's happened to the motion? Let's write one condition there. This experiment, right? Um, the right when real means that the speed at the lowest point is less than or equal. I'm writing in another way. So let's see that's what is as a question. Okay, what is the value of real? Is the value of real as particle just reach to the middle point. Middle point, that means the point M there. But remember that's the middle point I marked as M here. Okay, that's it. As the body will reach to this point, I'm asking that's what is the speed? Real should be there. Here like that. No, I didn't. Yeah. The mark says speed. Here. When the object just reach to this point, just reach me, the object come to there and the velocity becomes zero. Right? Just there. So then what happen? You can use the energy conservation for this one. Then I'm writing for you, then you can write using energy conservation. That's a half mvl square. C equals to, हम consider the potential energy zero is in this level and half m. Well, the speed at this point becomes zero because it just reached this point of zero plus mg, that's r, radius r is the height, right? Then m cancel, then you can write as VL square equals 2g. This 2 goes to the other side, m cancel, then square root of this. So that means the minimum 2g r speed should be there to reach the middle point. If the velocity at the bottommost point is less than this value, it will not reach to this point. It's somewhere between this L and M, the body speed will be zero. So then the second condition is that, second question, when the VL is less than square root of 2G, explain the motion of the body in the motion order. This something I'm given as a question, right? So you can write it down. This what's happened then? If this speed is less than 2G, so it means directly now you can tell that it will not pass the middle point in between L and M. The string will not be slack here because the weight is always downward. This before slack the string, the speed of the body becomes zero. Okay, then what's happened then? Motion. Okay, you can see here then body is there and there. So this the minimum speed we need to come to the body to the middle point. But that's the speed at the lowest point is less than this value. What's happened then? It will not reach this point somewhere here. The speed of the body becomes zero and then it turn back. So then it will oscillate about this point. So it's an oscillation. This is the condition for oscillating. Right. Then the reason is yeah, then the body cannot pass the middle point, and thereafter, after its return back towards initial position and due to inertia, do not stop at this point. Let's go to the other side of it. Cross the main position, the lowest position. So L and we'll oxidate about it. So it's oxidate. So there's a condition for oxidating next to it, the body. Okay. So then another one question is there. You can let me know that if you finish it. All right. Okay, then the last case is that's a third one. I'm writing in when this VL is less than square root of 5GR and the greater than square root of 2GR. Right, then after they explain the motion, right? Explain the motion of the particle. Now, this is the case now. And this is a VL here, and this middle point, and this is the highest. You know that's previously we discussed. If this VL is greater than square root of 5GR, only it can passes through this highest point, right? And if it is greater than 2GR, only it can passes this point. So that means if it is less than square root of 5GR, means it cannot reach the point H. If it is greater than square root of 2GR, means it passes the point middle point. So that means that somewhere in between M and H, somewhere here, that body is before the body stops, the string will slack. When the string is slack, the body becomes it's moving under gravity. So then due to that one, after that point, it will move like a projectile. So this is a position where the string slack. Position where the string slack. Okay, that thing is right there. In this case, and the other one, right, in this case, right, in this case, the body will cross. Body will cross position, cross the position M, and not enter, right, but cannot go up to capital H because the VL is less than square root of 5GR. So body will leave the circle, somewhere between M and H. And will follow parabolic path. So it moves as a projectile. Okay, so that is happening. Okay, these kind of questions, so they are in MCQ questions also. They asked in last year also. I saw that one question related to this part in the MCQ paper. We'll stop the class now. If you can go through it, then the questions are send you. Then go through the question. Also, some questions given, and then we'll discuss those questions and finish up the lesson. And next week we start the hydrospheric part. So we'll do some other extra classes also during this occasion.
Sir, next week
Yes.
institute එක ඇරලාද? මේ
මොකද්ද?
20 next week
මම හිතන්නේ last week එකේ වහලා අපි ඒකෙත් එහෙම එකක් online කරමු.
හරි sir.
මම බලලා ඉවරලා ඔයාලට message එකක් දාන්න.
හරි sir.
අපි ඒ වුණත් මේ බලමු මම extra class එකක් හරි අපි දැන් classes දෙක තුනක් කරමු extra මේ දැන් ලබන සතියේ පස්සේ ස්කූල් නිවාඩු දෙනවනේ. ඒකට බලන්න රෑ හරි. මොකද මට A level classes උත් මේ පාර A level එකේ ඒවා ඉවර වුණාම ටිකක් free time එකක් තියෙනවා. ඒකට බලලා ඒ ටිකේ කරගමු. හරිද?
හරි සර්.
හරි එහෙනම් good night පුතා.
Thank you, sir.